All right, today we've got a very exciting topic in store. We're going to talk about classes and objects. And as an overview, we've seen this foundation of programming diagram before. So far we've been all the way through the lower levels. So we learned about primitive data types and assignments. We've done input and output of text. We've learned to do conditionals like the if statement. We've done loops like the for loop. We learned how to do simple arrays, how to make programs that use graphics and sound, and things like that. We've learned how to make static methods, so functions, and how to package those static methods up into libraries that can be used by clients. And today we're at the final level of this foundation. We're going to learn about objects, and this allows us to build even bigger and more complicated programs and do it more easily, and makes it easier to debug things and makes it easier for other people to understand your programs. Here's an overview. We're going to briefly review primitive data types, so things we've already seen like the int and the double. And then we're going to spend most of the lecture talking about creating your own data types. We'll look at classes and objects and things associated with these, like instance variables and instance methods and constructors, and I'm going to show you an example of how to create an array of object variables. Just as a review, here are some of Java's primitive types, and I've put in dark black the ones we use most often in this course. So you've got the int. This stores counting integers, negative or positive integer values, and there's a certain range. You can't store, an unlimited sized integer in an int data type. You've got the double, which we use whenever we've got floating point data, so anything that has a decimal point. Then we have booleans, which are true or false values, and then finally the char, the character primitive data type, which stores an individual letter or symbol. Now you can do, a fair bit with just primitive data types, but there's some limitations of primitive data types. You only get a basic set of operations, and for the int data type, for example, you can add ints, you can subtract, divide, multiply, find the modulo remainder of two integers. But that's what you get. You can't create any new operations for this int data type. Say you want to do something different with an int variable, you're not allowed to add any operations. And probably a really big deficiency of primitive data types is you can't combine related information together in sort of an atomic package that must travel together. And we've seen this in some of our programs like Mars Lander. You have a bunch of primitive variables all associated with one thing you might think of as a single object. For example, your Mars Lander has a position, and it also has a velocity, and it has some other attributes like the images and the sound files and all these things, and they're really all associated with that Mars Lander, but they all were separate primitive variables in your program. In the radar contacts program, we were storing information about airplanes, and we were storing their coordinates, a northing and an easting coordinate and a call sign, but we had to have three separate arrays to track the information, and we had to just trust the programmer to keep things organized, so the thing in the third position of all the arrays referred to the data for that third aircraft. And in general, it's bad to rely on your programmers making keeping everything in sync, and a lot of modern languages have facilities to assist in that. And in Java, we're going to create classes, and so when we create your own data type, you have to learn a few bits of terminology, and the first bit of terminology is a class. And the way to think of a class is a blueprint for your own custom data type. You're going to invent a custom data type, for example, a Mars Lander, and the class file defines the blueprint for what things an object of type Mars Lander can do. And when we talk about an object, what I mean is it's a particular instance of this class. It's an instantiation of the blueprint. you may make a blueprint for a Mars lander, and you might have a game where it's a two-player game, so you might have two instances of that Mars lander blueprint, and these are two objects that are of type Mars lander. Two very important things, and I'll refer to this throughout the rest of the course. Objects have a set of things they know, and they have a set of things they can do. Things they know are persistent state of that object, and in the Mars lander example, things a Mars lander knows about itself are things like its position and its velocity. So persistent state of the object. Things the object can do, and for example in the lander might be able to update its position based on its current velocity. It may be able to check if it's out of fuel. It may be able to draw itself. They're things that the object can be asked to do, and then it will do them for you. Best way to learn about objects is to look at a simple example. So I'm going to give you a very simple class, and it represents a ball or a circle in 2 dimensions. And if we're going to design a custom data type that represents a 2D ball or circle, what do we need to know? Well, what does a ball need to know about itself? And it needs to know where it is, so it needs its x coordinate, its y coordinate, and it needs to know its radius. So this is the persistent state of a particular ball object. What sorts of things do we want this ball object to be able to do? And in our example, we're going to make sure it can draw itself, and we're also going to add something so it can print out its position and its radius to standard output, so to the console window. Here's how we do that in Java. We create a source file, Ball.java, and inside of there is a ball class. And this is just like what we've seen thus far. We have to make sure whatever file name our class is, it's in a file name exactly the same .java, and that includes case. We haven't seen this before. So normally we just have this public class ball, and then we implement a public static void main method to put our program in. Or maybe we put some static methods in there, and then we have a main program or whatever. Here is something we haven't seen before. Things the ball knows about itself are called instance variables. And they're like normal variables, but they're special in ways we'll look at in the rest of the lecture. They're accessible everywhere in the class, and they represent that persistent state. And remember, we said the ball 2D object would know where its x position was, where its y position was, and where its radius, or what its radius value was. It's just like declaring a variable inside your main method or inside of another static method, other than we've got this little private business on the front, and this is what's called an access modifier. And for the time being, we're going to declare all these private, and eventually we'll talk about the different access modifiers and what they mean and what they do. But in general, whenever you declare an instance variable, you're going to declare it private. Then you must give it a data type. In this case, these instance variables are doubles, so they can hold primitive double values. And then we have the variable name, and then we can have an option. Optionally, we can do a initial assignment. Now, in this particular example, recall that the double primitive defaults to being 0.0. So in this case, it's not strictly necessary, but often I do it just out of habit. Other languages don't have sensible default values, and so just to guard against bugs or bad habits, I usually declare and initialize my variables, even though in Java it's not strictly necessary. Here's our blueprint. Okay, and here's exactly what I said. These three things are instance variables. They must be declared inside the class but outside any other methods. So no fair putting them outside the curly braces of the ball, the public class ball curly braces, and no fair putting them inside any method inside that ball class. And so that takes care of what a ball knows about itself. Here is what a ball can do. Recall that I said that ball could draw itself and it could print itself out to standard output to the console window. And I've added two instance methods. They're pretty much like the static methods we've looked at so far. They still have an access modifier, and they have a public access modifier. They have a return value, and then they have a method name, and then they have an optional, they have a list of parameters. So in this case, both my methods don't return anything, so they have empty parentheses. But notice what's missing. Unlike our methods thus far, we don't have that static modifier. And that's what makes this an instance method. This draw method is associated with a particular instance of a ball. You may have 100 ball objects in your program, but this draw method is associated with one of those particular ball objects, and it will draw a filled circle at the position and at the radius of that particular ball object. Just as toString, and recall toString is the method that gets called if we were ever to try and print out. So if we had a ball object and we did system.out.println on the ball object, the toString method is the method that gets automatically called, and it generates a string. And I've just made my own little format up here. I've got the x position inside of parentheses, and then it prints out r equals the radius. So that's it. We've created our first custom data type, ball. It knows things like its x and y position, it knows its radius, and it also can do two different actions. It can draw itself, and it can print itself out to the console window, or return a string that can print itself out to the console window. Yep, so this is just what I just said. These are instance methods, and note there is no static keyword. Let's look at how to use that class. Just this class alone, this ball class, doesn't do anything. There is no main method. This program doesn't actually do anything. So you have to use it in a client program. And here's a ball client. And just like when we create an array, so it turns out an array is actually a class, a reference type in Java. And just like when we create an array, we have to create our objects before we use them. We do this using the same new operator we use when we create an array. This example creates two balls, a big one and a small one. This first bit on the left just declares I have a variable named big and it's of type ball, and I have a variable named small that's of type ball. The right hand side actually instantiates and actually creates that object and gives birth to that object, and then from that point on we're allowed to do stuff with big and small, like we can call any of these methods. So any of these instance methods we can call on the object big and the object small and make them draw themselves, and we can also call their toString methods by using the implicit call to toString that the system.out.println does. Notice we've got these empty parentheses here. This is saying I'm creating a ball object, but I'm not going to say anything in particular about how you should create this ball. All right, it's just a default ball object using whatever I set up as my state. So it's going to have an x position and a y position and a radius of 0, and that's it. If I were to run this ball client, and I could run it in Eclipse, but it would look pretty much the same, it does open standard draw, because big and small, they called their draw methods, and those draw methods actually made a call to standard draw and said please draw this ball. And where did it draw it? Well, it drew it at x equals 0, y equals 0 with a radius of 0. So maybe if you squint hard you might see there's a little dot down here in the lower left corner, and then it prints out its location and its radius to the console window. So not a very successful ball client, and I'm going to show you now how you can change the x and the y location, or create a ball object at any x and y location. So enter the constructor method. A constructor method is like a normal method, but it's a very special method. It creates objects. It is what gets called when you use this new operator in Java. It has a very special format. All right. First of all, notice there is no return type in this method declaration. It's not void, it doesn't return an int, it doesn't return a double, it has no return type, and it must not have a return type. Normally you're free to choose whatever method name you want for your instance methods, but not for a constructor. A constructor must be named the same as your class, including case. These are requirements, and then almost always, and everything we're going to be doing, it's going to be declared public. The only freedom you really have when you have a constructor method is what parameters it takes. What are the types and what are the number of parameters? And what I've done here is created a constructor where I can initialize the x position, the y position, and the radius by setting 3 variables when I call the constructor. What does that look like in the client code? Recall before we just had these empty parentheses after the ball. Now that we've declared this constructor, we're no longer going to use that default constructor. In fact, we can't anymore. Whenever we create a ball object, we have to very sensibly tell the ball object where it's located and what its radius is. And so simple as that. Now if I run this program, you'll get 2 ball objects showing up in standard draw at the position and of the size that was specified in the call to the constructor. Now, make sure you understand a common misconception people think is I've got this class file, right? And they look at this ball class and say, well, there's 1 bit of code and it has 3 variables. All right? And so how do I have, 2 different ball objects that are living in different locations? Well, this is just the blueprint, remember. I can create as many of these guys as I want. So in this case, I created 2 of them because I have 2 calls to the new operator. I actually have each of these, this big object inside of it, it has an x, it has a y, and it has a radius. It has those 3 instance variables. And the small guy, he also has those 3 instance variables. It's a bit boring having all our balls just be black. So let's make a more sophisticated ball object that can also have a color. And so to do this, we're going to specify the color using an RGB value, a red, green, blue value. And then before we draw the filled circle, we'll just set the pen color in standard draw. To do this, we're going to actually use another object. We're going to create an object of type color and create it with the proper RGB value, and then use that to set the pen color. We didn't create the color. There's the color class or the blueprint for this color object, but the good folks at Java did. And we're going to make our ball objects default to the very nice, lovely color mauve. And so it turns out mauve is about 88% red, 68% green, and 100% blue. What I've done to my ball object here is I've added a new instance variable. It's of type color. A object can have an instance variable that's a primitive value, but it can also have an instance variable that's another custom data type, in this case the color data type. And what color is doing is tracking the different RGB components of the color internally. And whenever you create something that's not a primitive type, you've got to remember you must use the new operator and create it. We're calling the color constructor here, and we're calling it with the 3 parameters. And it turns out in order to do this, the color constructor that the good folks at Java created only takes a float and not a double. And so that's what the little f is. This is saying this is essentially the same as putting a cast with the float data type. So if you just put 0.88, it won't work. It's kind of annoying, but that's the way it is. So the f just tells Java these are all 3 parameters or floats, and then it's happy and it will compile. Once we have created this color instance variable, then we can use it in our draw method, and it will make both our balls a lovely color of mauve. Very nice. A couple things you might notice here, and I've colored this the same as what you'll see in your Eclipse IDE. Whenever Eclipse has something that's an instance variable, it's going to color it in blue. So notice all these things are blue, and we can go ahead and I can open up Eclipse. Here are, here's my declaration. I've got position, position Y, radius, color. These are all instance variables. And notice whenever I use them, they're also in blue in the Eclipse IDE, whereas parameters or other local variables appear in black. So if I could declare something like, that, and whenever I use the variable foo, it just appears in black. And if I were to do something like that, okay, once it realizes it'll color it in blue too. So it's just a handy thing Eclipse does, so you can tell whether you're working with an instance variable or whether you're working with a parameter or a local variable. An important aspect of these guys, right? Anything that's an instance variable, despite being private, any of the instance methods in that ball class can access them. So it's like it's declared these variables are in scope inside the constructor. They're in scope in these other methods, so we haven't talked about overlap or set color, but all instance variables are accessible in any instance method of that class, but they're not accessible anywhere outside of the class. All right. And if we want, we can create a new method, set color, and this set color method takes 3 parameters, and I made them double for convenience, and then I create a new color object and store it. You can have a default value and then override it by either inside your constructor, like what happens with the position X and the position Y and the radius, or you can also have other methods modify these instance variables, like the set color method. Here's another client that just creates the big object and the small object and sets both the colors randomly. So every time I run this program, I'm going to get 2 balls. They're going to be in the same location, have the same size, but they're just going to have random color values. And that's important to understand, like that, they have different locations, and the color you set, setting the color of big has no effect on the small object, and vice versa. They both track their color independently of each other. All right, let's also talk about creating arrays of objects. So you could create a big and a small and a medium and a medium small and so on to get 7 different balls, but a more sensible way, and what we've seen with other data types, primitive data types, is you create an array of objects. And here's how you do it. I want to create my custom data type. It's of type ball. Empty square brackets denotes this variable is an array of that type, and then balls, lowercase balls, is just the local variable name. And I have to use new. So remember, whenever you create an array, you must have new and then the data type and then square brackets and the number of things. This creates 7 cups, each that can contain a ball object. That's the first step of creating an array of ball objects. But what is in the location of each of those 7 cups? When you first do the new ball bracket 7, what you end up getting is an array that contains 7 null values. And this special null value is the default value for anything that's of reference type. So anytime you create your own custom data type, or use a data type like color or string or any of the other stuff that's built into Java, if it's not one of those primitive types like int or double, its default value is this special null, and it's like an unprogrammed remote control. it can't control anything useful. It just has the potential to be programmed. You know, you can't control your TV yet, but once you program this, this one can control your TV, and then you could program this one to control your stereo, and this one to control your microwave or whatnot. You have to create an object in each position of the array. So this is a common problem I see with students, is they create their nice array of 7 ball objects, and then they go ahead and try and call methods on balls bracket 0 dot draw or something. That's gonna crash with a null pointer exception, because remember, this is the state of the world. After you've just created that array, all you have are null values, and you are not allowed to call any methods on any of these 7 positions until you actually create objects. So it's kind of a two-step process. First you create the array, then you loop over all the positions of the array and create a new ball object in each of those positions. And then I could set them to a random color. As I proceed through this loop, I would set ball 0 to some, you know, some random x and y and some random radius and some random color and so on. So each of the 7 in the array gets set to a different ball object. Alright, so very important. If you create arrays of objects, first create the array using the new operator, and then loop over all positions of the array and new an object into each of the positions in the array. Let's make a more complicated ball client. And this ball client now creates an array. And how big is the array? Well, the array is as big as I specify on the command line. It then loops over the array, creating a ball object with random size, position, color, etc. And we can go ahead and run ball client deluxe. And how many shall we run it for? Any suggestions? I don't know. Ball client deluxe. Yeah, let's run it for 1,000. Ready? Here we go. Yay! Okay. Pretty exciting, huh? We've actually created 1,000 objects and they've all been drawn. And there's no particular reason to do this other than just to demonstrate how to do this, because we don't reuse the balls in any way, but they would still exist. And so if I wanted to do something like, I've created, you know, this array of ball objects, and the nice thing is they stick around, so I could then go through them again and draw them. And so now if we were to run it, it draws it once, and then it draws it twice, but you can't really see, right? Just draws continuously. But well, we could do something like standard draw.clear. And then I think we gotta put a little delay in here. This is getting a little more involved than I anticipated. Okay, so you see the break. So you can keep reusing them. So that's the advantage of putting them in an array. That's all I was trying to show you there. What if we wanted ball objects to be able to detect if they overlap with another object? If we've got 2 ball objects, one's at x1, y1 with a radius of r1, and then we've got a second at x2, y2 with a radius of r2, do they overlap? And so you might pause the video and see if you can recall your geometry and come up with how might you do this calculation. How might you make a program determine whether these 2 ball objects overlap? So here's the answer. First of all, you've got 2 points, all right, the 2 centers of the ball objects. You can compute the Euclidean distance between those 2 centers. So just using the Pythagorean theorem, you can you take the difference of the 2 x's, square them, the difference of 2 y's, and square them, and then take the square root. And that will give you the distance between the center point of this one and the center point of this one. That just gives you your distance. Well, what does that say? Does it mean the blue one overlaps the red one or not? They do if that distance is less than the sum of the radiuses. All right. If you compute this distance and they're like, a million away, and this guy's, radius 10, this guy's radius 20, of course they don't overlap. It's only when that distance is 10 and one of them's of size 5 and the other's of size 8, well, then they're going to overlap. And here's a method to do that. And this method, I show you this, so this shows you how you might do that calculation. So down here we've got the square root, and we're computing the difference between the two x's and the two y's, and then the square root, and then testing is the distance less than the sum of those two radiuses. But this is kind of a special method because it's taking a ball object as a parameter. Overlap is an instance method inside the ball class, and so the overlap method is running on a particular instance of the ball. So maybe the red ball called its overlap method and somebody passed it the blue ball. The blue ball would be the other parameter, while the red ball would be the method that's running the object that is running the instance method of. And so in that case, if you did like red ball dot overlap blue ball, red ball, this position x would be the red ball's position x, and the position y would be the red ball's position y, and then other dot position x would be this guy's x, and other position y would be this guy's y. And this other is, this is just a local variable name. You could call this whatever you want. Other is, semi-traditional, and that's usually what I call it, because it's the other guy that's sort of the same type as you are. And a special feature of any instance method that takes a object of the same type as the instance method is allowed to access the private variables. So and other dot position x gets us that instance variable called position x in the other object, and this is how it's done. So it's like calling a method, except there are no parameters. Whenever you get an instance method, it's just the dot and then the name of the instance method. With the overlap method thus created, we can now create a super deluxe client. And the idea of super deluxe is you specify the number of ball objects on the command line. It then creates them, but it does it in a clever way. It creates them such that no balls can ever overlap. It creates a new ball just in a random position, but then what it does is it loops over all the existing balls in that array. Alright, and it detects if it overlaps, and if it does overlap, then it's going to just create a new random ball until it randomly creates one that's not overlapping any of the existing ones. And if you want to test your knowledge, you can kind of trace this out and or maybe trace it in the debugger and see how it's operating. I'm just going to show you the final product. So here's the same program in Eclipse, and we can specify how many things we want. And I don't know, shall we do 5,000? Oops, we gotta make sure. Oops, we're on the wrong one. Super deluxe. All right, let's run it at 5,000. And it drew some big ones, but as it got filled up, notice now it's being forced. The only ones that are succeeding now are very small ball objects that kind of fit in the margins between these big ones. So that's how it kind of runs. It always starts with the really big ones win first, and then all the other space gets kind of packed out with the little small balls. And this is an example of something that's easy. I mean, basically we've been able to build functionality to do something. It's not that you couldn't have produced this non-overlapping Super Ball Deluxe client thing without objects. It just helped us develop it sort of incrementally, and we can encapsulate the functionality of certain bits, like we can encapsulate this logic about overlapping in a very contained and reusable bit of code. And that's kind of the beauty of objects and object-oriented programming, is it helps us develop complicated solutions in pieces, and we can test each piece and reuse the pieces. to summarize, today we saw for the very first time how to create our own data types, and this is what's called object-oriented programming, or OOP. And classes are designed to encapsulate what a particular custom data type, what an object of that custom data type, what it knows about the world, and what it can do. And it's a prevalent concept. Most modern programming languages have object-oriented features, and so it's good to know. And I'll see you next time.